So hello, everyone. We're the next week on the API work group meeting. Let me share. This is the list of topics that I have collected to kind of work through this week. Share that. So, and I'll have to see if we have all the participants we need for the topics, but things that we had on, at least on the topic set, to kind of start to work through. The first one was a request to do a storage backend. I don't see Vipin on the call. He may still be out of the office. So that was something that he had put on the agenda to go back through and talk about a new storage backend concept that he was putting together. The next topic that we had was we started talking about how we were going to address some layering in terms of the overall API. And when we talk about the layering, we have to look at it from the standpoint of, what does the layering look like when we are a Kubernetes solution? What or how different may it look if it's a networking offload type solution that may include a SI? What would it look like in a cloud type topology, et cetera? So there's a lot of different layering thoughts that we could think about here. And I know Venkat was looking at putting something together. I don't know, Venkat, if you have anything put together yet.
Yeah, I know. Actually, a quick update on Vipin is in India. I'm not sure if he's joining. I tried to reach him. I did put something to start gathering thoughts, but I don't have anything complete yet because I missed some of the previous meetings. I feel if I go through them and then come back with a proposal, it will be useful to the team. But if we don't have if we have spare time, I may jump in and ask a few questions towards the end. That way, if and when I put something, it's a little more useful to the team.
No, that's fine. I'm trying to make sure that we keep these topics on our agenda list so that we can make sure we cover them. So,
got it. Thank you.
And then last week we were talking about how we were going to launch containers. We got to a certain point in the discussion last week. I don't know if we've come to any conclusion around that or if we want to continue that discussion. So I'll open the floor around how we're going to do container launching. And from that, we'll move on to any other topics beyond that. So any additional thoughts around launching containers as part of the discussion last week? Right.
Yeah, no more discussion. I did. Boris isn't here. He was one that was driving it. He posted on Slack to start a thread, and but just Dan Winship at some point had mentioned that talking about potentially running kubelet off, running kubelet off box, but he did not think that would work after talking to some more people within Red Hat. So whatever he suggested will not work, and that was documented in Slack anyway. So
yeah, so everybody take a look at the Slack thread around that particular topic, see if there's any other questions, and we can bring that up in any future meetings and hopefully close out this particular topic line. Okay, so the next one that we had on the list was our primary and secondary Kubernetes networking offload. I know we've had several discussions around that, so let's I'm going to go ahead and open up the floor for continued discussions on how we want to take a look at that networking offload. Do we want to consider breaking it into, I guess, two elements is, I guess, the way I've been kind of formulating it in my head. One of the elements is really focused on the provisioning functionality, where you essentially would go through the process of configuring, which would be setting up the interface ports, doing things like setting the MTU, et cetera, configuring any VLAN connections, IP addresses, VXLANs, et cetera. And then when all of that gets done, you're essentially exposing the interfaces up to the containers, which can be used. And then from that point, you're basically doing the CNI type of aspects or operations on those particular links. That was how I envisioned it. Is any comments to how that would be, or other thoughts around how that would be put together?
Yeah, so it's Donald here. I think
Yeah.
we could probably enumerate a few of the things in a little bit more detail. So from a provisioning perspective, on my kind of list, I had the underlay configuration, so of the DPU, so it's IP and so on and so forth. Any or overlay mesh, which is your VXLAN stuff and things like that for between your nodes in your cluster. There's any provisioning lifecycle stuff to do with provisioning the VFs between DPU and host, so that those resources are made available up to the guest. And then I think the other category that you were describing, I was thinking more of tenant resource provisioning. So yes, it is CNI related, but there's all the other kube control plane aspects of that networking infra for the kube, so including policy and ingress, gateway, load balancer, all of those aspects, which are tenant specific config is maybe the way to think of them.
Okay, no, that's good. That helps clarify it in my head. I mean, I'd broken it into the two pieces, but I see where you're coming from by even taking the provisioning and breaking it down further. So that's a really good view, Donald. Thank you.
And each of those kind of has a specific phase it needs to be done, life cycle and ownership and things like that, which is why I think it's worth subdividing slightly, because then we can actually try and pin down those characteristics of each of those.
Yeah, my thoughts around that were, as we look at it from those provisioning sub pieces, we can start defining what those APIs are, because they probably start to look more like a common API view across the different solutions, which could be cloud, which could be telco market space, could be networking, and then beyond that, you have what has to happen in the Kubernetes type operations for the tenants actually doing any tweaks or changes or particular things that they want to work on that particular exposed VF interface. Does that make sense from a group perspective?
Yeah, it kind of makes sense to me.
Okay.
For sure.
Is the layering we're talking about, in my own mind, I'm looking at maybe a physical networking layer, and then there is an overlay on top of that. That could be any of the VNet kind of architecture that's being overlaid on top. Is that the way you guys are looking at this as well?
Yeah, that's based upon the discussion we were just having. That's how I see it.
Yeah, that's typically the way we would. At least we are currently doing it. So I think, there's existence proof. Now, lots of people would look at this problem and partition it this way anyway.
Right. And then from those different partitions, we can come up with here's the common set of APIs that can be used across different use cases, work streams, et cetera. And then you'd have specific APIs that may be something very specific to cloud, something very specific to networking, something very specific to a Kubernetes type of solution.
Yeah, that's a good view, right? I mean, just pointing to Dash, where there is a clear, you assume that there is an underlay that just gives you basic L2, L3. And then building something on top makes it easy to think. I think we talked last time also that all the networking guys, at least we are used to think in terms of layers, and each layer gives you some abstraction, and then you kind of build upon, and then each layer is adding some functionality. So there may be more layers than this underlay overlay, but that's a good view, and it's proven to some extent, right? In the sense that how Dash is going gives us confidence, and there are a bunch of things we should take from them as best practices, or at least one of the choices for us.
Yep.
Okay. So somewhere along here, I may try to take a shot. I don't know if it'll be this week, because I'm out next week. But I've made some notes. I'll see if I can maybe start to put together a diagram that would show some of these layering approaches. And we can bounce it around and change it, comment on it, shoot it down, whichever way you want to work with it, that's fine.
So do we see Sai as part of this layering discussion we just had?
Yes, I could be part of this layering discussion. It's actually the next topic that I wanted to bring up, because it's been bouncing around some on some of the threads. So when we finish, if we're finished up at least on the Kubernetes networking offload case already, we can talk about what and how we want to look at Sai support for networking, because that may be a specific use case versus a more generic one.
Okay.
So any other views around primary and secondary Kubernetes networking offload? I know in the past we primarily talked about the primary aspect. Do we have some views around how we would address this secondary networking offload?
I have a proposal on the secondary part.
Sure.
So if we're talking about Kubernetes, right? First of all, we need like a CNI that will actually attach those virtual functions that you have from your DPU or IPU on the containers, on the pods. And I mean, we can actually start with the Multus approach, right? Where you can have one VLAN or many VLANs in selective trunk way. So maybe we can actually define each of those VLANs that you have as a logical bridge in our API, right? And then each virtual function can be like a bridge port to that logical bridge. So you create like networks access or trunk VLAN networks between your pods by subscribing to those logical bridges with a bridge port each time that you have. So this is an initial approach that maybe we can discuss.
Do you have a Demetrius, do you have a proposal for that approach that you could write up and maybe put into a pull request?
Yeah, that we plan to do that in the future. So
okay.
Yeah.
No, that would be great, because then we can actually bring it up and discuss it here in the team as the team, and people can actually go out and review the pull request independently with comments. So that would be good if you could do that.
Okay. Yeah, sure.
Great. Thank you. Okay. Any other discussion around primary and secondary offload cases?
So I had a question. I don't know if this is the right working group for that, but I'll bring it up anyway.
Sure.
So is servicing, a topic that should be part of the API discussion, in the sense that, if I'm going to be caching some flow state on the card and I want to service the card, typically I can't lose that flow state, and we need some mechanism to save and restore that flow state across that servicing event. And so to the extent that we are looking at, what we offload and how we keep that offload information, what state do we need to maintain, and what is the preferred mechanism to get a new set of bits into that offload card, which working group would that be part of?
That's a really good question.
Can I jump in? So I
Sure.
would presume it is this API group because you can look at it as an additional functionality in the sense that in the beginning, we may look at a set of APIs that bring certain services. And then, of course, high availability is part of that, but there may be an explicit additional APIs that will take it from that one node view to n node view. And some of it could be part of the infrastructure. When we define some of these layers, some of them will look like an infrastructure layer for the higher layer, and then some could be part of this whole controller orchestration layer. So I believe it will be part of this group, but at least it feels like we have to do some foundational things before we get there. But it's a good thing to kind of keep it in the list and track it.
Yeah. I would agree that it's part of the API group. It may have some overlap into the provisioning and lifecycle if you have to maintain it from that type of a perspective also. And then, of course, there may be where we have to create an additional group that kind of looks at service capabilities that are generic within a DPU environment. But that would be something that we'd have to create another group to actually start examining, so right now, I know within the API group, we cover the aspects of the API behavior, and we're eventually going to get into where we start looking at services that are there and how you can chain services together because you have the APIs that you need to use to chain services.
In the simplest sense, right, we could look at, are these APIs stateful APIs, meaning when I call these APIs, some state is established on the DPU or IPU, and that state is kind of difficult to recover. Or we could take an approach where these APIs are kind of stateless APIs where, let's say that system is running for a while and I've set up a bunch of configurations and things are happening. And now I want to re-image or bring in a new OS onto this DPU card, and I'm going to lose all the state that is sitting on the card. But before I do that, I would have an API that extracts in some way a serialized version of that state that can then be re-injected back after the system comes up, so that the DPU can re-establish its whatever state it had before this reboot occurred. That is something we could do. We're doing something like that, but I'm sure there are better ways of doing it than what I just described. But that's part of the API, flavor, if you will, that we would have.
Okay. Prasad, you've got your hand raised.
Yeah, so I have the opposite notion, at least. That's the thought we have in Marvel, that the orchestrator would already be in a position to either bring up another DPU with the exact same configuration, restore the configuration on this DPU. In that sense, the DPU doesn't have to do its own bookkeeping, is our thought.
Yeah, in some sense, I was just describing what you said, right? Which is there would be an API to kind of get the state of the DPU that can then be re-injected either onto the same DPU or a different DPU, depending upon what we're trying to do.
It's not. So basically, it's left to the orchestrator to. Okay, maybe you're saying one or more API. So whatever status updates the orchestrator gets, it's all part of the existing API. Let us say, those the DPU would provide, but it's not with the explicit purpose of being restored. That's the call that the orchestrator takes, that how it puts together the status and state information and decides to restore.
I think it'll be nice to have that as part of the overall architecture, because servicing is obviously an extraordinarily important attribute. And, in some cases, the state cannot be lost because the only way to recover the state is to restart the VMs, and that's a no-no.
Yeah, and you may need something additional to the external orchestrator or the orchestrator itself to handle HA type operations. Because you may need some sort of more of an automated way to do the switchover.
I'll add one more point on HA. So HA is something we consider slightly differently, where maybe DPUs are aware that there is a counterpart that they can collaborate with to ensure automatic. So that would be an explicit DPU, inter-DPU functionality, probably symmetric DPUs, homogeneous, if you will. So I think HA from a DPU managed HA perspective slightly different, and orchestrator managed HA would be DPU agnostic. A DPU wouldn't be aware of that load balancing. The thought.
I'm not even talking about load balancing or anything, right? So let's say that I have just one DPU, and for whatever reason, I need to upgrade the software stack on the DPU. So what would be the flow for doing that? This is not for increased performance. This is not for increased resiliency. I mean, one could argue that, if I had two DPUs, I could shift all the workload from one DPU to the other and then update the software here and bring it back. That certainly is possible. But is that the only architecture we would support? Do we support in-place upgrade of the DPU stack, which would require some state management, either some way of serializing it and re-injecting the state? Yeah.
I'm not aware of the latter part. I don't think I've been in any discussions that requires an explicit state extraction and restoration.
Okay.
But it should be okay to, as part of life cycle management, I think that's another group we have, maybe Boris or someone knows that better. I think there is a plan to facilitate things like upgrades. There are things that DPU specific metadata that the DPU would continue to retain. So there are some parts there, persistence, if you will, is available. Some parts of the persistence is addressed there, but not so much the runtime configuration. The stuff that's configured via OPI, API, currently, I don't think there's any persistence angle to it.
The life cycle management would be handling things like software upgrade, how you would do it without or minimizing the impact to the tenants, or try not to impact the tenants itself. That's, I think right now the focus in that group has been around how you handle the boot sequencing when you're going through the upgrade and things like that are happening. I think that's the current.
Open-ended extraction of state and replaying that state on another DPU. That sounds like a scary proposition, right? It could, it'll be very hard to have a universal definition for that. State for what? An application level state, OS level state, hardware level state. There could be so much state in a complicated device like DPU. It would be hard to come up with a definition of what a state means.
The way I would look at that is, if I were to simply reboot the DPU, and for whatever reason, what does it take for me to make that event completely uneventful to the VMs running on that host? And even if I had an impact on the tenants, impact on the VMs, is that impact simply kind of a blackout for a small duration? Or would it require that the VMs all restart simply because I don't know exactly what VNet mappings were and so on? And so I need to.
Right. It's one thing to say that the VM shouldn't even notice, so the actual network interface or the VF or the PF stays alive while there are some retries being issued, right? That's one level at which you can say the VM on the host does not notice that there's been an event on the DPU. But if there's some kind of service chaining happening, there's certain offload happening on the DPU for which the DPU and the VM are interacting with each other. Having a universal definition for not having an impact on that flow would be extremely hard. At a superficial level, yeah, I mean, we've seen cases where you don't want any disruption of the host driver controlling the PCI functions. I mean, that's one level at which you can say the VM should not notice something. But anything deeper than that, I think will get very complicated.
Well, I do know that the lifecycle group is looking at the boot cycling, KY. They are trying to figure out how, if you have to power cycle a DPU, how the DPU can alert the host and do that in a proper fashion. This may be a good additional topic to bring up into that thread. But it may be outside of the current scope of what they're discussing right now, but it may be something that needs to also be considered.
Yeah, I think there are 2-3 variants to the high availability. I think one of them belongs there, where you are trying to do something gracefully and you're giving enough time. Still, there's some applications will depends on the SLAs, right? There is also discussion elsewhere, not in OPI, on how DPUs can synchronize. How do I say it? Like a millisecond or a nanosecond level, right? Where everything that's happening, there is a back channel, there is a synchronization, there is a backup. So so the loss is minimized. So there are different levels. And then to the previous point, right? I do agree. State, if we just applications know their own state and they can synchronize and they can come up with their mechanisms, but a generic state synchronization is not easy. But again, we will be digressing if we get into that here, at least.
Okay. Any other topics on our primary, secondary offload around that?
I think the state management requirement are different between the primary and secondary. So the primary is under the Kubernetes contract, and it is mainly used for the in-cluster communications. And if we are offloading the primary, we also need to consider offloading network policy and the kube-proxy. And offloading those functionality requires typically the connection tracking maintained by the DPU. So that is the state we need to manage in the DPU. The secondary is not under the Kubernetes contract, and it's typically used for the external network communication. And also we can provision the separate VXLAN for the secondary, because the secondary network, it doesn't have to be used for the in-cluster communication. And the state management is also up to the use case for the secondary.
In fact, I was referring to the policy state that Toshi was talking about, right? Which is, if you're going to be kind of applying some policy and allowing some flows and preventing other flows, that flow table that's already reflecting the policy in place, that flow table, if it is lost, then you have to essentially reboot the VM. So we can't afford to lose that the state that we have offloaded that captures the policy that was in effect, and that thing needs to be restored if it is sitting in memory or FPGA or whatever on the DPU card.
No, but the policy was configured in the first place using
it was
API.
It was configured, but what you have lost is now the VM has made some connections. There were some inbound connections that it accepted, some outbound connections that went through. Applying the policy. Now, usually what we do is we apply the policy on the exception packets on the DPU. And so if that state is lost, the only way to recreate the state is to restart the VM and have those connections again come in and either approve or disapprove those connections based on our policy. So that flow state is really key for us to keep the VM downtime really, very minimal. Preferably, you just want to, during the servicing interval, it's okay for us to say this VM cannot create any new connections because our policy engine is down. But the existing flows that we have offloaded to some piece of hardware on the DPU that can continue to work even when we're changing the software on the SOC.
Okay, thanks for explaining that.
Yeah.
Okay. Anything else on this particular topic? I'll keep it. I will still keep it on the topic agenda because I'm sure we'll come back and visit other areas of this. But anything else we want to discuss today?
I think just on the primary and secondary, our working assumption at the moment is that we need to be able to offload everything for the primary, or it's all about the primary. So not assuming that we would have secondary interfaces into KubePods. So some of the issues that are being talked about here, I think, are quite relevant about whether or not kubeproxy functionality can be offloaded and things like that. I think we'll need to drill into that in more detail in a subsequent conversation.
Okay. I will put that as another agenda topic to discuss. All right. So let me move on to the next topic that's in here. We've had a couple threads related to SCI support for the networking aspects. And is that really just a specific use case that's like a network switch specific, or is it more generic and reaches across other potential use cases? So let me open the floor to that discussion.
I'm driving, so I'm unable to raise my hand. So I'm going to jump in.
Oh, go ahead, Venkat.
Yeah. So I think it is generic, right? There are a couple of things that are happening which are interesting around SCI. We all know how useful it is or has become for multi-vendor. And then maybe that's old news, right? But what is new is especially how pipelines are being defined with P4, not as a, I mean, let me rephrase, right? P4 as a modeling language, right? And then specifying certain functionality in the pipeline and auto-generating the APIs for that new functionality is happening. And what is interesting to me is that it is connected to SCI in the sense that even SCI is evolving to absorb these new DPU-centric APIs. So this is a change from the fixed functionality functional API side. Suddenly you have programmability coming in there. So and there are multiple projects going on around that. All that I feel would be very relevant to us. Dash pins project, which is again Sonic plus some programmability happening at Google and other places. So in that sense, it gives a good multi-vendor infrastructure for us to use. OPI being, we're trying for common APIs and programmability is in our name. So I think, this has a lot of value for us. Even while we build our layers, there is a layer where this, SCI and where SCI is heading has a lot of value for us to reuse than reinvent something else.
So with Venkat, just would you see Psi as being under a DPDK layer? Would you see it as parallel to a DPDK layer? And I ask that simply when you look at a lot of what's available today, a lot of things feed through DPDK, or they're going to go into a particular SDK that's vendor specific, and sometimes there's even DPDK over that SDK.
Yeah, so I don't have a good answer. I need to maybe draw. Like I said, for layering, I started putting some material. I may need to draw it and see. But one attempt I'm making there is to really forcibly put a P4 switch, forcibly put DPDK, forcibly put Psi, right? The reason is that it'll surface the issue and we'll be able to answer. So I don't have an answer, but one thing why we should be thinking, leaving all these things in an open manner and see where they fall, is there's quite a bit of translations and adaptation layers being done across, across the industry, right? I've seen eBPF and P4, and then DPDK, P4 backend for DPDK. I mean, all these variants exist out there, and then there's more of it is happening. Like even last week, I saw some really interesting work. So while I don't have a good answer for you now, but when we have this so-called layer diagram, then we should be able to explain all these. Otherwise, people who are using either P4 or DPDK, they'll say, okay, this is what I'm using, OPI, what can I do with you? And we won't have a good answer for them. So I know I'm not answering you, but I see there is a method to how we can get there.
No, it's okay if you don't answer me, because I was posing it to you, but I'm also posing it to the whole group, because there's all these layers.
I have something to add here. This is Chris. Can I respond to that question, Mark?
Sure.
So the way I look at it is Psi is just an abstraction for a network switch, and maybe even a stateful device like a DPU, describing network type configuration, network service configuration, routing tables, things like that. And DPDK or any data plane implementation would sit under that abstraction, and ideally no one cares what's underneath it. It's just a C-level API description of a network configuration interface. And if you were to put an RPC server on top of that, you'd have a socket-based API to configure a network switch, and you can consider that an external interface if you wanted. Not that people use it that way. It's normally linked in and bound to some kind of a server daemon that does a lot of things. But implementations include today DPDK, which is part of the IPDK package. There are P4 implementations. There are silicon ASIC switch implementations, etc. So Psi is just an abstraction layer for a switch, configuring the switch, and we don't care what's underneath in principle. Does that help at all?
I think it helps some. The question is Psi above or below some of those layers, right? Or is it intermixed?
Well, just to clarify, DPDK is just an implementation technology that might be used to implement Psi. So Psi is above. Psi is, let's say it's a data plane abstraction layer where there might be applications on top of it that are more useful for a network operating system. And below that is, some kind of an abstraction of a switch device. And DPDK might be the implementation. So it would be under Psi, right? DPDK is not an interface, it's a technology.
Okay.
Just had a quick question. So how mature is Psi when it comes to non-switch devices? Has there been a lot of work along those lines? Venkat did mention that they're addressing DPUs. I'm just curious.
Well, I would say the only things that are you might want to call non-switch device. I don't know if there's such a thing as a non-switch device for Psi because they're all switch-based type devices, but Dash is adding a whole level of let's say complexity in terms of stateful service configuration. It's operating at maybe a scale and with statefulness that normal switch ASICs can't process. So that's why they're using XPUs for that. And as far as maturity, it's still a work in progress at the community level, but there are predecessors to the official Dash version that's being defined. There are predecessors in production using non-community interfaces. And we've seen, yeah, thanks, Mircha. We have seen demonstrations in this working group of devices that are being used in production for the Dash predecessor. Dash is kind of let's say it's a canonical version of some of these early production deployments. It's being made into more of a commodity approach, much like Psi and Sonic. And so it's not mature in terms of, you know, real world deployments, but there's an awful lot going on that we've played with in our labs and have been demonstrated in various forums where it's pretty real. And you know, I would say there's going to be, you know, some serious real hardware implementing this with mature stacks on top of them in the coming, you know, year.
But for DPU specifically, the focus of that project will continue to be just switching, right? Not a wider set of use cases. The project itself is not fundamentally redefining itself to address non-switching use cases.
Not that I'm aware of. The only other thing that you might want to consider non-switch is more platform management. There's something called a Phi-Psi layer that is a generic abstraction for physical layer devices, you know, like transceivers. And it follows the same kind of, let's say, design patterns as switch control Psi APIs. And it's just convenient because it provides a multi-vendor interface to control transceivers, which have historically been, you know, very different, and they all have different HALs and different vendor SDKs. Phi-Psi tends to unify that across a standard, simple, table-driven type of interface as well. But that's more, I would think of that's more like almost like platform and not really a whole new application, you know, like on the level of switching. So as far as like storage, no, there's nothing for storage.
Okay. Marcia, you have your hand raised. Marcia?
Must have stepped away. He posted something in chat, a link to Dash.
Okay.
Or sorry, Psi. He linked a link to Psi. And the experimental directory in Psi. Oh, he has mic issues. Right now, Psi is, sorry, Dash has API.
I think I'm back.
Oh, there you go. Yeah, go ahead, Mircha.
Yeah, so when I posted about it, I was thinking more about on the lines, vendor A may choose to implement OPI APIs natively, whatever that means for them. But other vendor may say, hey, I already provide the Psi interface. Do you guys, meaning OPI group, mind creating a bridge between your OPI API to the Psi? Because Psi provides a way to configure the IP on the interface already, to create ACLs, to do flow tracking, to get certain stats. So bunch of features could be there, and some vendors may choose to say, hey, I already provide them via this interface, just map your API to this interface and keep going. You already have the feature. And Psi could be extended as well with requirements from this group, if needed.
True.
Yeah, I mean, if I can comment on that, I mean, the OPI API that we are going to use for networking should be like abstract enough, right? And then underneath should have like a pluggable framework that can actually work with Psi or any other vendor plugin in order to support the IPUs, DPUs that we have. Is that right, or?
That could be one of the ideas and one of the approaches.
Mm.
I guess I would just, as a devil's advocate, say if we come up with abstractions for OPI, you know, greenfield abstractions, and they're not really that different from Psi themselves, then we have to ask, why are we reinventing, right? And that's just a devil's advocate question.
And to my understanding, the Psi is basically important interface, but it is used by the Sonic network operating system to support multi-vendor switches. And the Sonic is there to maintain the database so that it keeps the desired state and program to the switch to basically make sure the switch state is consistent to the desired state the network operating system maintained. So if we bypass the network's operating system, then the caller has a responsibility to maintain the database and making sure the switch state is same as the caller's requested state. So it's, to me, it's basically giving up the responsibility of the network operating systems. So I think the OPI API needs to be on top of the network operating system. And the network operating system should be the one maintaining the desired state.
Interesting point. So I guess what you're saying is you couldn't just put a wrapper or adapter layer, you know, this bridge between an OPI interface and Psi, because you need more intelligence inside that layer.
Right.
Although the bridge could be responsible for ensuring that it's doing what was asked of it, right? And
right.
if you want to call that a network operating system, that's fine. I'm not sure I would go so far as to call that a full NOS, but it's definitely an orchestration or something, which yes is part of Sonic. But Sonic has so many layers inside of it. You know, you don't want to try to pull that whole definition of Sonic into the bridge for this proposed.
Right. From the end user's point of view, let's say I'd like to use like a Terraform to provision the DPU. And in the same way for the multi-vendors DPUs, Terraform is now really checking the DPU state every moment, right? So it just provision and basically maybe check the previous state, but it's not maintaining the state. So it is the responsibility of the network operating system. Once the request is received, it is responsible to sync up the desired state to program into the switch, and the switch state and request the desired state are in sync.
Yeah.
When the switch or DPU rebooted, the network operating system needs to program it again based on the state it is maintaining.
Well, it's a good point. I guess you could probably make that same observation about any OPI API, that any client that exercises an API expects the device to execute it faithfully or throw an exception, right? And take care of all the messy details.
Yeah. That would be correct.
Well, you could even, I don't want to get in trouble for saying this, but you could even create an OPI to Sonic, I'd say the Redis database, for example, or Sonic GNMI interface. You could create an adapter if there were reasonable mappings to go from some OPI interface to Sonic, and because Sonic's going to be running on a lot of these DPUs, the entire Sonic, a large part of the Sonic stack is going to be running on these dash DPUs. Right. It won't have the SDN, let's say the control plane type applications like BGP, for example, might not be on there, or some other application, but it will have a lot of bits of Sonic, and you could adapt OPI to Sonic the appropriate northbound interface of Sonic, or maybe even a Redis DB interface, and let the Sonic stack take care of all this orchestration and housekeeping. I'm not necessarily recommending that as an architecture, but it could be done, and that would address this orchestration aspect.
Yeah, as one aspect, yes, Sonic could be that layer. You could use OVS as that layer. You could use some sort of networking OS framework as that layer, you know, because there are proprietary ones out there.
Yeah. By the way, Psi is also being used in FBOSS at Facebook. They've converted to using Psi, and they've done a number of presentations about that at the Open Compute Project Global Summits. And there's other NOSes that are going to be adopting Psi, and we'll read about that in the near future.
Okay. Good. All right. No, that was a good discussion. Any other discussion around this topic? Okay. So I think from a perspective, one of the things that we need to address, I mean, we'll go back and revisit the different topics that I had listed up earlier, plus any additional ones. But I think we need to go back and start really re-looking at the layering. I know we have some older layering diagrams, but we really should probably go back, revisit those diagrams that are out on the GitHub site, and let's see if we can do some updates to them to clarify some layering approaches, and work through that so that we can start then driving out more of the API solutions, as well as going back through some of the contributions or getting additional contributions around some of these different use cases. So we can then also determine what are the common API aspects versus things that are specific to a particular market or use case, you know, such as cloud, because we have a full cloud submission that's in there that Vipin had done. We also are looking at some inputs, I think, from Intel and Ericsson around a demo that they did using VXLAN and EVPNs. So, okay. And since we've only got about 4 more minutes, I will go ahead and give you guys back a little bit of time so you can get to your next meetings or whatever you need to do for the day. And I will work this week on, or the remainder of this week, I'll work on finding someone to host the meeting for next week, since I'll be out. All right, everyone, have a good week.
Thank you.
All right, thank you.
Thanks, everyone. Bye.